We've got another quick video for you. Just like inclined planes, for wedges, we need to define what the effort distance is, define what the resistance distance is, and once again, kind of figure out the funky thing about the resistance force. So again, your IMA equation is essentially the same. We're just tweaking a couple letters to match up with how wedges actually operate.
The wedge is essentially an inclined plane that we're kind of tipping to go straight up and down. You can think of it as more of like a tapered or a very skinny edge that we typically use to drive and split objects. We can think about it as a doorstop trying to pinch objects. But essentially what a wedge is our inclined plane that is tilted perpendicular to where it originally is. So for a wedge, as far as the IMA goes, kind of similar to the inclined plane, is we need to define what the effort distance and the resistance distance is for our special simple machine. So for our effort distance, that represents the distance traveled by the effort. Now for the inclined plane, remember, it was the slope of the object. That's not the case for the wedge. The wedge, the DE is the distance traveled, so that is the entire height of the wedge. We're not taking into account that slope or that slant. It's the entire height of that object. So our DE, we still kind of symbolize as L or length, but that is the length that our wedge is supposed to travel as we drive it into maybe like a block of wood or a chisel into some concrete or something like that. Now our DR, our resistance distance, is what is that doing to the object that we're putting the wedge into? And so our resistance distance is kind of pushing those objects out as we drive it down. So we measure resistance distance just by the height of our object. And now for the wedge, the height is from the top of the wedge, essentially what you would drive like the axe head or maybe using a hammer for the chisel. We're not talking about height like this. We're talking about the height is essentially the width of our wedge. And that's something to kind of work on because that might be a little bit confusing. So our IMA as DE over DR, in the case of a wedge, is the length or the perpendicular height divided by the height or essentially the width of that wedge. Now for AMA, our calculations are exactly the same, but one thing that we do need to point out is our effort force is going to be straight down on top of that wedge. It's going to produce forces going both ways, like if we were using an axe to split some wood. So we are applying a force straight downwards on that wedge, and it is popping the pieces of wood out in both directions. Our resistance force, when you're looking at diagrams, is only one of those. So if you have a picture that shows the resistance forces going both ways, we only have to take one of those into account. So that's another special thing to keep in mind for the wedges. So again, kind of in conclusion for our wedges, our effort distance is going to be that height. We represent that as L, or that's kind of our perpendicular distance. Our DR is represented as height, but it's essentially the width of that wedge. And when we're talking about resistance force, especially in picture form, we're only taking into account one side because that's the amount of force that's popping out on both sides.